Good morning, ladies. Docker is a development platform that is used in the industry when building, shipping, and deploying software. Docker is basically a gay version of a virtual machine that's sole purpose is just to run code. The whole idea behind Docker is to keep your infrastructure and your applications separate. Docker creates isolated containers that run on the Docker virtual machine. Each of these containers are specific with their OS and dependencies needed for execution. So if you want to run a React application with Docker, you would use a Docker container with ideally the most recent version of Node. Then you can specify all of the NPM packages that need to be installed: React, React Router, React DOM, etc. Every time that you run a Docker container, it uses a fresh flash of the OS, required dependencies, and runtime data. Hey dumbass, did you hear that? All runtime data will be wiped from the Docker containers when they are shut down. Unless you're smart and write this data to some sort of file structure. But what does all this really mean? I really believe that Docker was created because the developers were tired of hearing, "It runs on my machine." Docker containers are pretty cool, if you're a fucking nerd like me, but they are not to be confused with virtual machines. Let's compare a virtual machine and a Docker container in reference to a Python program. If your end goal was just to execute the Python program, it would be much more taxing on the host machine to run it on a virtual machine in comparison to a Docker container. But why is this, I hear you asking? I know you didn't ask that, but just go along with it. One of the many reasons for this phenomena is that a virtual machine emulates an entire new instance of an operating system, meaning the host machine has to manage its operating system, the virtual machine's operating system, and the code being ran inside of the virtual. Virtuals are also much more isolated from the host machine, which can actually become a crutch when working with multiple Docker containers at one time. For instance, a VM has its own kernel, unlike Docker containers which share the host machine's kernel with the rest of the containers. So in terms of resources, Docker containers prove to be much more efficient, as they share the host operating system, kernel, and hardware, making them much more capable for high-octane computing. There are multiple levels to the Docker ecosystem, starting with the Docker engine. The Docker engine is the core of Docker. It operates on the management layer of all containers. Moving on, Docker images are like the blueprint for Docker containers. This means that they contain the source code for the project, the Docker file, more on that in a minute, and the dependency list needed for execution. There's a bunch of nerd shit that I could go into about the Docker image, but I'll save that for you as it's really not that interesting. Psych, bitch! The Docker image is fucking sick! There are so many different types of images that you can create for writing different types of programs. Python, Node, Java, JavaScript, Go, C#, fucking everything. When you finally pick the language for the project you're going to stop updating next week, you can start by creating the Docker file. A Docker file is the brain for the blueprint of your Docker image. After you specify a language with the from keyword, there are many more keywords that can be used to specify commands to run, dependencies to install, Git packages to pull, etc. And when you're all done with the Docker file and the source code and the dependency list, use this image to create your first container. Personally, I recommend uploading your Docker image to AWS and maybe scaling to 1 million containers or more, but make sure that you enable the paid plan. For legal reasons, that was a joke. But for real, when you run the image, the language, dependencies, etc. are all automatically installed and the program is run. My most favorite feature about Docker in general is that they never fucking work the first time. I mean, seriously, in 5 years, I've never written and deployed a Docker image that works the first time. If you want to run a multiple container program, you'll need to use Docker Compose. I really haven't dabbled much with Compose before, so I'm only going to briefly touch on this. The whole idea behind Compose is to interlink any containers that rely on each other during execution. And to do this, use a Docker Compose file. Inside of the Compose file, you can set the specifications for how you want the containers to interact. For instance, you can set the ports that they use to communicate, how the containers scale, and so much more. So yeah, pretty much the last thing I want to touch on about Docker is just how widely used it is today. At the start of my development journey, I never really understood how the computers that would run my code would have the dependencies that were needed, the version of the language of my choice, and all of the other stuff that's needed to run a program. But pretty much every single one of those problems is solved with Docker. It really is a build once and deploy everywhere kind of deal. So if you're just starting out in development, I really recommend getting at least familiar with Docker, because if you really want to pursue this path, you will see it all over the place in the industry. And being able to say that you know Docker and Git, stay tuned for my video on Git, is pretty much a surefire way to get a job that pays you $400K a year working at Google. And the most important part of the video, what do I think of it? 7.5 out of 10. I like the color blue that they used in their logo.